In this video, we're going to take a look at some different notation for linear functions that you may be getting used to now. So this is a bit of a review for you, but just to run through how things are going to look when you are working on your homework and your quizzes and tests so that it's matching up to. In this video, we're going to take a quick look at linear functions and the different notation. You've been working with it a bit, so just somewhat of a review here for this first part, and then we're going to do some word problems. So we have slope-intercept form, f of x equals mx plus b. The slope of the line is b, where f of 0 is what we have for x is 0. That's where it hits the y-axis. The slope of the linear function f can be found using 2 points. So in function notation, it looks just kind of cumbersome there, but it's really just saying your first x and your first y, but the y is in function notation f of x sub 1. Same here, x sub 2, f of x sub 2. So when we write the slope formula for a linear function, it's very similar how we were working with average rate of change with a and b, but here we're just using the x values. And the y values are represented using the f of x notation. So point slope form, probably familiar with as well, but that's just solving out for the y's, the difference in the y's. And your slope formula is how we get this, f of x minus f of x sub 1 equals m, which is your slope, quantity x minus x sub 1. And what we do here is just leave the x as a generic, just as x without a subscript in both of those spots. M is the slope, and we have any point, and this is a typo here, I just noticed, so this should be x sub 1 and f of x sub 1 right there. So if you just want to fix that on your sheet, try to get that edited shortly. Examples, we have p of x is a linear function and p of 0 equals 7. P of 3 equals 5. So it's the same gist, just using different letters to notate our functions. So what we want to find is the equation for p of x and sketch its graph. So in your prior lesson for part 1 of all this, you had just going through like writing equations and things like that and seeing it in this notation in a little bit of review as well. So if you want to go ahead and try all these on your own, that'd be great. I'm going to walk you through a couple of them, and then I'll leave some for classwork. And then for a sketch for the graph, just truly just a real, rough sketch, like kind of, is it real steep? Is it kind of not steep at all, just almost like a flat line? So just kind of get that gist. So the first thing we want to do is kind of pluck out the points here. So that would be x is 0 and my y is 7. So I just write it as a point. Same here, I would have 3 and 5. And then right off the bat, I know I have the y-intercept, so I can label that as b here. And then I just need to find the slope, so I can just subtract those there. I'm just finding the difference in my values. So just pause. I'm going to just write that up. I think you can probably manage to get this first one done on your own and then check back. So hopefully that went smoothly, and you can see here it's just the same as you would have worked with an equation, but it's just using function notation. P of x equals negative 2/3 x plus 7 is our function, and here's the sketch. Right over here I have a down 2/3, so just kind of roughly sketching that in. doesn't have to be on graph paper or anything for these. And this is really P, or we could say P of X. So number 2 is a little bit different. This is kind of where we want to look at the notation carefully and look what's happening and kind of substitute things in. So the first one that we're given, m of t is a linear function, and m of 0 equals 2. So the first piece of information, I have that 0.02. So that's nice. I have the y-intercept. But here, this looks pretty different. I am not given just a point. I'm given the difference in the y's. So it's telling me the difference in the y's is 4. So m of 3 minus m of 1 is 4. So remember, slope, another way to write that, put that over here, is going to be difference in y over difference in x. And so this little triangle means delta in the Greek. So delta y over delta x. So right here, that 4 is actually delta y, or in this case, it's m, but we're doing like the generic. So my slope, I have the numerator there is 4. But how do I know what the denominator is? Well, I'm given these x values inside. So it would be 4 is the top, and then 3 minus 1. Do go left to right for these to make them work out right. It would be 2. So then I have 4 over 2 equals 2. So that's my slope. I have my y-intercept here. So B is also 2. So I'm going to have y equals 2x plus 2, except instead of y, I want to write it as m of t. So we want to look at what our notation is given as. And instead of x, we want to write that as t. But at first, if you want to just work it out as x and y, sometimes that helps people to just kind of be more familiar with it, but don't forget to go back and change that up. And then our little sketch here would be, kind of go down this way. So I have a positive slope. I have a 2 for my y-intercept, and then I would be up 2 over 1, down 2 left 1, so kind of like this. And of course, if you were doing it with paper and pencil, you could just use the edge of anything to make a straight line. Okay, and then just mark m of t and t. And that's it for the sketch. Next problem, you could try this one on your own now that you have more information, but just to set you up for it, this would be h of y equals is a linear function, and h of -2 equals 0. So figure that point out. So it's not your y-intercept, but it'll be your x-intercept. And then you have the difference in the y's here. H of 1 minus h of 0 equals 1/3. So that's the numerator in your slope. So then figure out what the difference is in the x's for your denominator. The x's are inside the parentheses. And then remember to get your sign right. Just kind of work left to right on those. That's how the notation kind of works out, because it's based on this. This is really your second x. That's your first x. So to be consistent with how that numerator was figured out, you need to subtract the 1 minus the 0 instead of vice versa. All right, so try that one as a classwork, virtual classwork. The next one, number 4, you can try that one also. This would be k of x is a linear function, and we have k of 0 equals 3. So again, I have my nice point there to work with. And this one's a little bit different because I have the numerator given as -1, my delta y, except the x's, this should look kind of familiar to you guys at this point. My x's, I don't have just numbers in there, I have expressions. So it would be x plus 1 minus x in the denominator, and that should kind of look a little bit familiar to you when we did average rate of change, when we did difference quotient and things like that. And then I'll come back and do number 5. So if you want to do 3 and 4 as classwork, and then I will come and do number 5. So just check back for the answers on 3 and 4, and then I'll start up with 5. Okay, so let's take a look at number 3 that you have for classwork. And this one is a little bit different because I'm not given the y-intercept, so I have to plug into y equals mx plus b. So I have my point -2, 0, and then I figured out my slope. I put the 1/3 in the numerator. I have 1 minus 0 as my difference in x on the denominator, so it just comes out to 1/3. So then I just plug in the values for x, y, and m into my slope-intercept form. You could use point-slope form as well, like either one. The prior video went over that process as well. So then we go ahead and just solve for b, and I get 2/3. So I go back here and do h of y equals 1/3 y plus 2/3. So I'm switching back. So now it's kind of weird because you're like, well, y is x. Oh, what's up with that notation? Sometimes, you know, it might mean years or something like that. That's why the notation and defining your variables is really important. And labeling, like my sketch over here, I have to make sure the y is the independent variable and the h of y is the dependent variable. H depends on what, you know, y is, what the input. So it doesn't matter what letter you call it or anything like that. It's what is the input, what is the output. And so be aware of that. So when you look at a y, don't always assume it's just the output. That's just the generic way we talk about our x and y in general. So now the number 4 came out to be, b was our 3, and then I had to find the difference for the denominator here. I had -1 was my delta y. My delta x was x plus 1 minus x, giving me just 1. So these cancel out, right? And then I have k of x equals -x plus 3. So I hope that went well for you. Let me know if you have any questions. For 5, we're going to do that one together just in case like 3 was a little tricky for you. It's kind of similar to that. So kind of mixing a mix of 3 and 4 actually. So here we have b of t is a linear function, and b of 1 equals 4, and b of t plus 4 minus b of t equals 3. Find an equation for b of t. So here I have the point 1, 4 that I'm given. I'm also given delta y is going to be 3 for my slope formula. Remember, that's delta y over delta x. So my delta y is 3, and my delta x is going to be t plus 4 minus t. You don't really need to have the parentheses in there, but I would just put them for emphasis. And then these will go to 0. So I end up with my slope is 3/4. I don't know my y-intercept yet, so I'm going to plug into y equals mx plus b. I'm just using the generic just to, you know, write out and pop in. You don't actually have to write that every time. But then I have my y value from over here is 4. My m that I found was 3/4, or it's 3/4. The x that I'm given is 1 plus b. B is what I'm trying to find. So then I just go ahead and multiply these out. So I have 4 equals 3/4 plus b. subtract 3/4 from both sides, and I get 3 1/4 equals b. So then I can write my function b of t equals 3/4 t plus 3 1/4. You could write that as an improper fraction if you wanted, as 13/4 would be fine also. A lot of times we like that better, so, but it just depends on the problem and the context. In my Open Math, it usually tells you which one it wants. And I'm not having you do the sketches on those last couple. I mean, I think you get the idea. You're not always required to do that. So I hope that helps. The videos for number 6 and will be coming up. So as an example, see that in a separate video. And then for number 7, the snowplow problem, go ahead and just try that one and see how you do with it. And for number 8, I will make a video for that example as well, but you can always just go ahead and try any that you want to try on your own and then check back. You can even do the whole packet if you already know it. Just go ahead and go through, but do check your answers against the video. You just can kind of click and drag and get to where you want to know. You just want to make sure you're matching up and getting things correct and not just kind of going through and submitting something that's doesn't match up. With 8, if you do that one on your own, just be careful about what you pick for your variables. Make sure you're thinking about what is the independent variable and what's the dependent variable. Okay, so you might want to check just the beginning of the video, like set it up and then check it. But the math actually is not too challenging on that one, other than there's a little bit of fractions involved.